Welcome back, and in this lesson I want to start talking about S3 security in more detail, starting with bucket policies, which are a type of AWS resource policy. So by now you know the drill, let's jump in and get started. Now before we start I want to repeat one thing, and you will have heard me say this before, but I'm going to say it again over and over. S3 is private by default. Everything that we can do to control S3 permissions is based on this starting point. The only identity which has any initial access to an S3 bucket is the account root user of the account which owns that bucket, so the account which created it. Anything else, so any other permissions, have to be explicitly granted, and there are a few ways that this can be done. The first way is using an S3 bucket policy. And an S3 bucket policy is a type of resource policy. A resource policy is just like an identity policy, but as the name suggests, they're attached to resources instead of identities, in this case, an S3 bucket. Resource policies provide a resource perspective on permissions. The difference between resource policies and identity policies is all about this perspective. With identity policies, you're controlling what that identity can access. With resource policies, you're controlling who can access that resource. So it's from an inverse perspective. One is identities and one is resources. Now, identity policies have one pretty significant limitation. You can only attach identity policies to identities in your own account, and so identity policies can only control security inside your account. With identity policies, you have no way of giving an identity in another account access to an S3 bucket. That would require an action inside that other account. Resource policies allow this. They can allow access from the same account or different accounts because the policy is attached to the resource, and it can reference any other identities inside that policy. So by attaching the policy to the resource and then having flexibility to be able to reference any other identity, whether they're in the same account or different accounts, resource policies therefore are a great way of controlling access for a particular resource, no matter what the source of that access is. Now think about that for a minute, because that's a major benefit of resource policies, the ability to grant other accounts access to resources inside your account. They also have another benefit. Resource policies can allow or deny anonymous principals. Identity policies by design have to be attached to a valid identity in AWS. You can't have one attached to nothing. Resource policies can be used to open a bucket to the world by referencing all principals, even those not authenticated by AWS. So that's anonymous principals. So bucket policies can be used to grant anonymous access. So two of the very common uses for bucket policies are to grant access to other AWS accounts and anonymous access to a bucket. Let's take a look at a simple visual example of a bucket policy, because I think it will help you understand how everything fits together. There's a demo lesson coming up soon where you'll implement one as part of a mini project, so you will get some experience soon enough of how to use bucket policies. Let's say that we have an AWS account, and inside this account is a bucket called Secret Cat Project. Now I can't say what's inside this bucket because it's a secret, but I'm sure that you can guess. Now attached to this bucket is a bucket policy. Resource policies have one major difference to identity policies, and that's the presence of an explicit principal component. The principal part of a resource policy defines which principals are affected by the policy. So the policy is attached to a bucket in this case, but we need a way to say who is impacted by the configuration of that policy. Because a bucket policy can contain multiple statements, there might be one statement which affects your account and one which affects another account, as well as one which affects a specific user. The principal part of a policy, or more specifically the principal part of a statement in a policy, defines who that statement applies to, which identities, which principles. Now, in an identity policy, this generally isn't there because it's implied that the identity which the policy is applied to is the principal. That's logical, right? Your identity policy, by definition, applies to you, so you are the principal. So a good way of identifying if a policy is a resource policy or an identity policy is the presence of this principal component. If it's there, it's probably a resource policy. In this case, the principal is a wildcard, a star, which means any principal. So this policy applies to anyone accessing the S3 bucket. So let's interpret this policy. Well, first, the effect is allow, and the principal is star, so any principal. So this effect allows any principal to perform the action S3 get object on any object inside this secret cat project S3 bucket. So in effect, it allows anyone to read any objects inside this bucket. So this would equally apply to identities in the same AWS account as the bucket. It could also apply to other AWS accounts, so a partner account. And crucially, it also applies to anonymous principals, so principals who haven't authenticated to AWS. Bucket policies should be your default thought when it comes to granting anonymous access to objects in buckets, and they're one way of granting external accounts that same access. They can also be used to set the default permissions on a bucket. If you want to grant everyone access to Boris's picture, for example, and then grant certain identities extra rights, or even deny certain rights, then you can do that. Bucket policies are really flexible. They can do many other things. So let's quickly just look at a couple of common examples. Bucket policies can be used to control who can access objects, even allowing conditions which block specific IP addresses. In this example, this bucket policy denies access to any objects in the secret cat project bucket unless your IP address is 1.3.3.7. The condition block here means this statement only applies if this condition is true. So if your IP address, the source IP address, is not 1.3.3.7, then the statement applies and access is denied. If your IP address is 1.3.3.7, then this condition is not met because it's a not IP address condition. So if your IP address is this IP address, the condition is not matched and you get any other access that's applicable. Essentially, this statement, which is a deny, does not apply. Now, bucket policies can be much more complex. In this example, one specific prefix in the bucket, remember, this is what a folder really is inside a bucket, so one specific prefix called Boris is protected with MFA. It means that accesses to the Boris folder in the bucket are denied if the identity that you're using does not use MFA. The second statement allows read access to objects in the whole bucket. Because an explicit deny overrides an allow, the top statement applies to just that specific prefix in the bucket, so just Boris. Now, I won't labour on about bucket policies because we'll be using them a fair bit throughout the course, but they can range from simple to complex. I will include a link in the lesson description with some additional examples that you can take a look through if you're interested. In summary though, a resource policy is associated with a resource. A bucket policy, which is a type of resource policy, is logically associated with a bucket, which is a type of resource. Now there can only be one bucket policy on a bucket, but it can have multiple statements. If an identity inside one AWS account is accessing a bucket also in that same account, then the effective access is a combination of all of the applicable identity policies plus the resource policy, so the bucket policy. For any anonymous access, so access by an anonymous principal, then only the bucket policy applies, because logically, if it's an anonymous principal, it's not authenticated, and so no identity policies apply. Now, if an identity in an external AWS account attempts to access a bucket in your account, your bucket policy applies, as well as anything that's in their identity policies. So there's a two-step process if you're doing cross-account access. The identity in their account needs to be able to access S3 in general and your bucket, and then your bucket policy needs to allow access from that identity, so from that external account. Now, there is another form of S3 security. It's used less often these days, but I wanted to cover it anyway. Access control lists, or ACLs, are ways to apply security to objects or buckets. They're a sub-resource of that object or of that bucket. Remember in the S3 introduction lesson earlier in the course, I talked about sub-resources. Well, this is one of those sub-resources. Now, I almost didn't want to talk about ACLs because they are legacy. AWS don't even recommend their use and prefer that you use bucket policies or identity policies. But as a bare minimum, I want you to be aware of their existence. Now, part of the reason that they aren't used all that often and that bucket policies have replaced much of what they do is that they're actually inflexible and only allow very simple permissions. They can't have conditions like bucket policies, and so you're restricted to some very broad conditions. Let me show you what I mean. This is an example of what permissions can be controlled using an ACL. Now, apologies for the wall of text, but I think it's useful to visualize it all at once. There are 5 permissions which can be granted in an ACL. Read, write, read ACP, write ACP, and full control. That's it, so it's already significantly less flexible than an identity or a resource policy. What these 5 things do depend on if they're applied to a bucket or an object. Read permissions, for example, on a bucket allow you to list all objects in that bucket, whereas write permissions on a bucket allow the grantee, which is the principal being granted those permissions, the ability to overwrite and delete any object in that bucket. Read permissions on an object allow the grantee just to read the object specifically as well as its metadata. Now, with ACLs, you either configure an ACL on the bucket or you configure the ACL on an object, but you don't have the flexibility of being able to have a single ACL that affects a group of objects. You can't do that. That's one of the reasons that a bucket policy is significantly more flexible. It is honestly so much less flexible than a bucket policy to the extent where I won't waste your time with it anymore. It's legacy, and I suspect at some point it won't be used anymore. If there are any specific places in the course which do require knowledge of ACLs, I'll mention it. Otherwise, it's best to almost ignore the fact that they exist. Now, before we finish up, one final feature of S3 permissions, and that's the block public access settings. In the overall lifetime of the S3 product, this was actually added fairly recently, and it was added in response to lots of public PR disasters where buckets were being configured incorrectly and being set so that they were open to the world. This resulted in a lot of data leaks, and the root cause was a mixture of genuine mistakes or administrators who didn't fully understand the S3 permissions model. So consider this example, an S3 bucket with resource permissions granting public access. Until block public access was introduced, if you had public access configured, the public could logically access a bucket. Public access in this sense is read-only to any objects defined in a resource policy on a bucket. So there's no restrictions. Public access is public access. Block public access added a further level of security, another boundary. And on this boundary is the block public access settings, which apply no matter what the bucket policies say. But they apply to just the public access, so not any other defined AWS identities. So these settings will only apply to when an anonymous principal, somebody who isn't an AWS identity, attempt to access a bucket using these public access configurations. Now, these settings can be set when you create the bucket and adjusted afterwards. They're pretty simple to understand. You can choose the top option, which blocks any public access to the bucket, no matter what the resource policy says. It's a full override, a failsafe. Or you can choose the second option, which allows any public access granted by any existing ACLs when you enable the setting, but it blocks any new ones. The third option blocks any public access granted by ACLs, no matter if it was enabled before or after the block public access settings were enabled. The fourth setting allows any existing public access granted by bucket policies or access point policies, so anything enabled at the time when you enable this specific block public access setting, they're allowed to continue, but it blocks any new ones. The fifth option blocks both existing and new bucket policies from granting any public access. Now they're simple enough and they function as a final failsafe. If you're ever in a situation where you've granted some public access and it doesn't work, these are probably the settings which are causing that inconsistency. And don't worry, I'll show you where these are accessed in the demo lesson. Now before we finish up, just one final thing I want to cover, and this is an exam power-up, so these are just some key points on how to remember all of the theory that I've discussed in this lesson. When I first started in AWS, I found it hard to know from instinct when to use identity policies versus resource policies versus ACLs. Choosing between resource policies and identity policies much of the time is a preference thing. So do you want to control permissions from the perspective of a bucket, or do you want to grant or deny access from the perspective of the identities accessing a bucket? Are you looking to configure one user accessing 10 different buckets or 100 users accessing the same bucket? It's often a personal choice, a choice on what makes sense for your situation and business. So there's often no right answer, but there are some situations where one makes sense over the other. If you're granting or denying permissions on lots of different resources across an AWS account, then you need to use identity policies because not every service supports resource policies. And besides, you would need a resource policy for each service, so that doesn't make sense if you're controlling lots of different resources. If you have a preference for managing permissions all in one place, that single place needs to be IAM, so identity policies would make sense. IAM is the only single place in AWS you can control permissions for everything. You can sometimes use resource policies, but you can use IAM policies all of the time. If you're only working with permissions within the same account, so no external access, then identity policies within IAM are fine, because with IAM you can only manage permissions for identities that you control in your account. So there are a wide range of situations where IAM makes sense, and that's why most permissions control is done within IAM. But there are some situations which are different. You can use bucket policies or resource policies in general if you're managing permissions on a specific product, so in this case S3. If you want to grant a single permission to everybody accessing one resource or everybody in one account, then it's much more efficient to use resource policies to control that base level permission. If you want to directly allow anonymous identities or external identities from other AWS accounts to access a resource, then you should use resource policies. Now finally, and I know this might seem like I'm anti-access control list, which is true, but so are AWS, never use ACLs unless you really need to. And even then, consider if you can use something else. At this point in time, if you are using an ACL, you have to be pretty certain that you can't use anything else because they're legacy and they're inflexible, and AWS are actively recommending against their use. So keep that in mind. Okay, well that's all of the theory that I wanted to cover in this lesson. I know it's been a lot, but we do have to cover this detailed level of security because it's needed in the exam, and you'll be using it constantly throughout the rest of this section and the wider course. At this point though, go ahead and complete this video, and when you're ready, you can join me in the next, where I'm going to be talking about another exciting feature of S3.